Hi, this is Professor Fernandez. This is video 2 in lesson 11. We're talking here about the quotient rule. Before I tell you that, I'll just mention that we're going to do 2 examples of using the quotient rule that come from Calculus Simplified. Okay, so let me scroll down here. I have put down copied in here what the quotient rule is from Calculus Simplified. This is theorem 3.7 in the book. As you may imagine, right, the quotient rule is the derivative rule for quotients of functions. So the derivative of f of x divided by g of x. And this is probably the longest derivative rule that you might have to, commit to memory somehow. But I'll give you the way that I do it. There are lots of different ways to help you remember this rule. The way I do it is I remember, first of all, the product rule, right? So remember the product rule, f of x, g of x, the derivative rule for products, is f prime of x, g of x, plus f of x, g prime of x. Okay. If you want to see some examples of that in action, check out video 10.3 in this series where I talk about the product rule. But the point I wanted to make here is that notice that this and the numerator of the quotient rule look almost the same. The only difference is that in the product rule you add, in the quotient rule you subtract. In other words, if you remember your product rule, which I hope you do in a calculus class, then you basically already know the numerator of the quotient rule, which is, as you can see, the most complicated part of the formula. All you have to remember there is you just change the sign. Quotient rule subtracts. And then, of course, you got to remember that the quotient rule, somewhat unsurprisingly, produces a quotient. So you have to remember the denominator, which is g of x squared. Okay, as I said before, there are many, many ways to remember the quotient rule. So pick the one that works best for you, but I always find this useful because you're kind of combining, what you already know, the product rule, and reapportioning it to some other purpose to help you remember the quotient rule. So this first example, let's see what it says. Differentiate h of x equals this. First of all, we do want to recognize that we need the quotient rule. And at this point in the course, you want to think a little bit about that. Can you do this problem without the quotient rule? If you can, then I would use a simpler rule. Quotient rule is not overly complicated, but it does take a little longer than using some of the other rules. For example, to go off topic here, I would not recommend using the quotient rule on this. You could. I have written it as a quotient of two functions, but instead I would write it as x to the minus 2 and then use the power rule. That's much faster. Okay, back to the example at hand. So this one, there's really no other way for me to write this that is going to be any faster. I could write this as x squared minus 1 times x cubed plus 1 to the negative 1. I could do that. Then I would be using a combination of the product and chain rules. It's going to take about as much time as it would with the quotient rule, so I'll just go ahead and write out the quotient rule. Okay, so h prime of x. What I'm going to do here is I'm going to, instead of identifying f and g and then writing the formula and doing all the derivatives, it'll make this a lot longer than it has to be. I'm going to embed that into the actual calculation. So quotient rule, derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. See? So what I've done here is I've written out the quotient rule, f prime g minus f g prime over g squared, except I've actually put in what the f and g are, right, from the function. So I've saved myself a little bit of time, and I've also slowed things down a bit. I didn't actually try to calculate this derivative while I was putting it into the quotient rule formula. Okay, that'll be the next step. So derivative of x squared minus 1. So I'll send you again, if you are in need of some review, to videos 10.1 through 10.3. They talk about the rules we're about to use, specifically the power rule and also the rule for the derivative of a sum and difference of functions. Okay, so derivative of x squared minus 1 is the derivative of x squared, which is 2x, minus the derivative of 1, which is 0. And we keep the next term. And then minus x squared minus 1 times the derivative of x cubed plus 1, same deal there. Derivative of x cubed is 3x squared, and then the derivative of 1 is 0. And then we divide this by x cubed plus 1 squared. Okay, depending on who is your instructor, or if you're studying this by yourself, you can certainly stop here. This is the answer. It is not the most simplified form of the answer, but you could go off and simplify this. For example, you could multiply in this 2x to that term and that term. You could multiply in this 3x squared there. you can see that this first one, for example, is going to give you 2x to the fourth. This term multiplied by that is going to be 3x to the fourth and subtracted. So there's some simplification that you could do here. I won't do this in this video because that boils down to algebra. We've done the calculus already, right? We applied the quotient rule, which is the point of this video. So I'll skip that step. You can certainly see the rest of the simplified answer in the solution to example 3.29 in Calculus Simplified. And instead I'll go over here and talk about this next example. So differentiate h of x equals x plus 1 over x. Here is a good illustration of what I had mentioned earlier. If you can avoid a lot of calculation, right? Why not? Go ahead and avoid it. And in this case, we can. So I'm going to do this by avoiding that calculation first, and then I'll go back and do this using the chain rule. How can I avoid calculation, a long calculation here for the derivative? Well, I could go ahead and divide each one of these into x. So if I do the first one, I get x over x. The second one, 1 over x. So this function, h of x, is equivalent to the function 1 plus 1 over x, which written in derivative-friendly form would be 1 plus x to the minus 1. So the derivative there would be the derivative of 1, which is 0, and then plus the derivative of x to the minus 1. I bring down the minus 1, subtract 1, and there we go. This, even with me, talking it out every step of the way, was a fairly quick calculation, right? Derivative of this h of x function is minus 1 over x squared. Now let's see what it would have looked like if we had done this using the quotient rule. So let's go ahead and do that. So derivative of the top, right, times the bottom minus the top times the derivative of the bottom over the bottom squared. And then we do out each one of these. Derivative of x plus 1, that's just 1, times x minus x plus 1. Derivative of x is also 1, and then divided by x squared. This, again, is the answer. It's not simplified. In this case, I will simplify it because I want to compare it to this and hopefully get the same thing. So let's see. We have x minus x plus 1 over x squared. Distribute the negative 1, divide by x squared, cancel the x's, and voila. Same answer indeed. Check. So you can see here that we've done the differentiation two different ways, and it illustrates the point that I made earlier that you really do, at this point in the course, we've talked about several rules for differentiation. You want to find the one that's going to work fastest so that you don't spend too much time calculating the derivative. Particularly with the quotient rule, there are instances, and this was why I put this example on here, where you may want to go ahead and divide things out or simplify in some other way so that you avoid using the quotient rule. It is one of the longest derivative rules to use. Great, thanks for watching.